So for number 13, we have similar directions. Find the domain of the function below. But we've got a piecewise function with two rational function parts. So let's review the domain again. No division by zero ever. No square roots of negative numbers. That'll give us an imaginary number. And no log base b of 0 and no log base b of negative numbers. These two are by agreement in high school math. And then this one can't be answered. That's a question that can't be answered. So let's go take a look at that. So I have graphed here an exponential function y equals e to the x. So as we go bit to the left of the y-axis, we get fractions. So it's e to the negative of a x value, so it's a fraction. And we can never actually get to y equals 0. So the way to think about log base b of x, this asks the question, b raised to what power equals x? So if I say log base b of 0, and I'm taking the base of that logarithm, so what power can I raise that base to and get 0? There is no number where I can do that. So it's a question that can't be answered. So going back to our problem, okay, so for this part, I'm going to factor everything I can. So 2x plus 13 is not factorable, and the denominator here factors to x plus 1 times x minus 1, and then that's x less than 0, and the second piece, 5x minus 26 over x plus 2, x is greater than or equal to 0. So for this part, x can't equal negative 1, x can't equal positive 1 here, x can't equal negative 2. But this is not going to even come into play because this part only applies when x is greater than or equal to 0. So by the time we get greater than 0, this denominator can never be 0. So we only need to worry about the top function, and this only applies when x is less than 0, so we really only have to worry about x can't equal negative 1. So our domain and interval notation is going to be negative infinity up to but not including negative 1, union with negative 1 to positive infinity. And we'll go check the answer. They agree. And then I want to show you how you can put this in the calculator. So I'm going to go here. I've already put in my piecewise function. And if I go to a new function and go to the palette O math, this is the two-piece piecewise function template, and then this is the n-piece piecewise function. So I'm going to go ahead and hit 2 there, hit OK. So at that point, I could put in this function. And the best way to move between the rectangles in a template is to hit Tab. So I'm going to get out of that. Okay, so I've got my function here. And then I'm going to go back to go add a calculator page. Then I'm going to go to the catalog that looks like a big open book. I'm going to go to the domain function, and if I go back, it tells me down here how to use this function or this command, domain expression comma variable. Now I've already got the function defined in F2. So I'm going to go down to F2 of x, so that's my expression, comma x. And it doesn't give it to us in interval notation, but we see that x cannot equal -1. So that concludes this video.